I noticed something I had missed out in the last video, so I've added it in here. Now, we know that if we get the most significant bit as a value of 0, then the path that this takes is along here and down through the shifter and then out through in this direction. But you'll note here that if we have this value of 0 and we head down in this direction, it means that we're going to shift this entire value left by a value of 1. Now, if we shift this entire thing left by a value of 1, the question is, what's going to drop in here in the least significant bit? Well, previously I just added a 0 in for this least significant bit and it was always just a 0. But that isn't quite right, because what we want to do is whenever we shift this left by 1, in effect we want to shift the whole 48 bits. But of course I can only do these 32 bits at a time. So what I want to do is shift this most significant bit up into this position. Now that's okay if this most significant bit of this is a 0, then it's fine, it'll still work. But what would happen if the most significant bit here is actually a 1? We would want to shift the 1 up in here. So for example, now we come down through this path, and you'll notice I've got an extra adder and I've got this extender and I've got the splitter here. So now what's coming out is, what was coming out previously was the 0, 0, and when I shifted it left, it would just drop a 0 in. But we don't want to do that, we want to drop the most significant bit of this number in. So we really want to drop this bit in. So now if you see if I change this to a value of 1, you'll see that we're actually dropping in the most significant bit here. And you can see I've done this through a little splitter, so it's the same as this splitter here. We grab this bit here and we bit extend it to 23 bits, but it'll still just be a value of 1 or 0. And if it's a value of 1, we add that value of 1 on to the original value. Okay, so we'll now get a value of 1 or a 0 in that least significant bit.